Hi, I'm Katie, a rising senior at the Brewerly School, and I completed my first milestone, for my Forearm computer, which is connecting a humidity sensor and a barometric pressure, altitude, and temperature sensor to an Arduino and have the data displayed on a screen. So this is the device. This here is the Arduino Uno, and it's sort of the brain of the whole project. It's powered by this 3.3 volt lithium ion battery, and the battery is connected to this, which is the battery charger. And right now, all it's doing is connecting the voltage and the ground wires to the Arduino's voltage in and ground. But later, I'll be able to charge this using the USB. So the Arduino is connected to both the barometric pressure and temperature and altitude sensor, as well as the humidity sensor and the screen. This is an OLED screen, and an OLED screen means organic light emitting diode, and an organic light emitting diode is where you have two electrodes in a layer, and in the layer in the middle is a organic material, and whenever a current is sent through the organic material, it lights up. And so if you sort of send a current in a different place, you can get a pixel, and then when you sort of manipulate where you send the currents through, you can end up getting words on the screen. So both the screen and the sensor are communicating with the Arduino using I2C, which is just a means of communication. I2C requires that you have one device, which is the master, and up to 121 devices, which are the slaves. And so the screen and the sensor are the slaves, and the Arduino is the master. So the master can initiate communication. It commands the slaves to send a data or to display data, and it also I2C is synchronous, which means that the clocks of all the slaves and the master have to be the same, and so the master sort of uses its clock onto the other devices. One of the I2C requires two wires to connect, one of which is the SCL wire, which is serial clock, which makes sure that they're on the same clock. The other is serial data, SCA, which sends the data across. So basically, the Arduino commands to this sensor to send its temperature data, and its barometric pressure data, and its altitude data. It receives that, converts it to the right units, then sends it to the screen where it displays temperature, humidity, pressure, and altitude. The I2C requires that you have two pull-up resistors, one connecting the SDA wire to high voltage, and one connecting the SCL wire to high voltage, which basically eliminates noise from any of the sensors. This here is the humidity sensor, and it's not connected using I2C. It just has a voltage and a ground pin to power it, as well as one output voltage pin, and that goes into one of the analog pins on the Arduino. So depending on the humidity, the humidity sensor will send out a low voltage for low humidity or a high voltage for high humidity to the Arduino, and to the analog pins, the Arduino can read exactly what voltage is coming in, and then it uses calculations as well as the temperature data from this sensor to determine what the relative humidity is, and then using I2C sends that as well to the display.